Okay, good morning, sir. I'm Eng, and my group partner is Wan Muhammad Azlan. I'm from Group 1, so I will start explaining the part 1. So a brute force attack is a method used to break encryption or password by systematically trying every possible combination until the correct one is found. So there are 4 common types of cryptographic transformations, which are the DES, the RC2, RC4, and also AES. So for the first question, the computer tries 1 million keys per second. So the total number of possible keys is 2 power of 40. So we want to find maximum amount of time to try all possible keys. So we use 2 power of 40 divide 1 million. So we get 13 days. So if you want to convert from seconds to minutes, we divide 60. From minute to hours, we divide 60 again. And then from hours to days, we divide 24. So for question 1.2, the computer tries 1 million keys per second. The total number of possible keys is 2 power of 128 because we use the 128-bit AES. So we want to find the maximum amount of time to try all possible keys. So we use the 2 power of 128 divide 1 million. So the answer we get is 1.079 multiply 10 power of 26 years. So for question 1.3, we compare the answer from 1.2 to the age of universe. So the brute force attacker is unlikely to crack a document sealed with a 128-bit AES key because the maximum amount of time required to try all possible keys, which is approximately 1.079 multiplied 10 power of 26 years, far exceeds the age of the universe, which is around 13.5 million and 14 billion years. As of now, the security provided by the 128-bit AES key remains extremely robust against brute force attack. For question 1.4. So although the technology advancements may reduce the amount of time needed to crack a document, however, it is still require a very long period of time to successfully breach the security provided by a 128-bit key. Thus, our secret still safe from any attack. Now we proceed to question 1.5. For this question, total number of possible keys is 2 power of 128. So we will calculate the key tried in the first 18 months first, which correspond to 1.5 years. So we use K0 equal to 1 million, multiply 60, multiply 60, multiply 24, and multiply 365. Lastly, multiply 1.5 years. So we get 4.7304 multiply 10 power of 13 keys. Then we calculate the key tried in second period of 18 months. So we use K1 equals to 2 multiply K0. So it's equal to 9.4608 multiply 10 power of 13 keys. So from the calculation above, we get a generalizing for the n period. Kn is equal to 2 power of n multiply K0. Now we perform the geometric series. So the total keys tried is Ki equals to K0 in bracket 1 plus 2 plus 2 power of 2 until the 2 power of n. So we get a formula which is K0 bracket 2 power of n plus 1 minus 1. Next, we will find the n. We use the formula obtained from previous calculation, which is K0 bracket 2 power of n plus 1 minus 1 is more than or equal to 2 power of 128. So we get n is around 82. So lastly, the maximum amount of time to try all possible keys is 82 multiplied 1.5 years, which is equal to 123 years. So for extra credit questions, why a 192-bit or a 256-bit share secret would provide more security than a 128-bit share secret? This is because the 128, 192, and 256-bit keys undergoes 10, 12, and 14 rounds of encryption, respectively. A round consists of several processing steps, including substitution, transpositions, and mixing of the plaintext input to transform it into the final ciphertext output. The more rounds there are, the harder it becomes to crack the encryptions, and the safer the original information.
Hello, I am Muhammad Azlan, and I'm going to talk about the task 2. Firstly, we need to create a file named motd.txt, and inside the file we type university. And after we save the file, we open the command prompt, and we type certutil-hash file motd.txt sha256 to encode the file. Certutil is used to manage the certificates and keys. We specify the algorithm that we want to use, which is SHA256. And as we can see here, we can get 64 hexadecimal digits output is generated. And for 2.1, we will copy University Technical Malaysia Melaka into our file. And then we will encode the file again using the command prompt. As you can see here, we can get 256 bits output is generated. And next, we will copy University Technical Malaysia Melaka and add a new line to it. And again, we will encode the file using command prompt. And we can see 256 bits output is generated, which is completely different from the previous one. And for 2.2, we will copy a long text into our file and try to encode it using CMD. And the hash value produced for question 2.1 and question 2.2 are completely different, because SHA-256 is highly sensitive to any change made to the input data. Even adding just the new line will result in a completely different 64 hexadecimal digit, no matter how long are the text. SHA-256 will always produce a fixed length hash value of 256 bits. That is 32 bytes.
That's all from us. Thank you.